Good morning. We'll start with the first module for the industrial automation subject. Uh, First, we'll have introduction to the automation. We'll see what is automation, and then we'll switch to the main part of this subject, that is module number 3. That is automation of the processes by using pneumatic, hydraulic, electro-pneumatic, electro-hydraulic, and PLC uh, setups, so that you'll have a detailed idea that what is done exactly in case of process industries, and how we can manage the processes, how we can more automate the processes, how we can achieve maximum production rate, how we can optimize the cost, how we can use the labor smartly, and how we can increase the profit, and how we can reduce the loss by optimizing all the processes that come, or that are involved in the manufacturing of any object or equipment or any product. So here uh, we'll discuss about the basic elements of an automated system, then we'll go to the advanced automation functions, and then we'll see what are the levels, the different levels of automation, and then we'll go to the principles of automation and all, and this is how we will complete the introduction about this automation in the industry. Next is this diagram will show or will tell you what is exactly the meaning of this automation system, or how exactly the system works. Now here you can see uh, at the bottom there is a manufacturing processes and assembly operations. One block is there. Okay, now into this block you can understand, or you can consider the number of manufacturing processes, that is just like cutting, bending, and surface finishing, or joining, welding. So different or number of processes are considered, and the parts are manufactured, and those are assembled together to prepare one unit, one product, or one object. Okay, or one machine, or one unit. So which is made up of number of small parts, or number of parts which are performing a different function, and when assembled together will perform uh, main function of that unit. So this is about the block manufacturing process and assembly operations. Then you can see the automation and control technologies. Now here uh, the actual part is considered, that is related to the industrial automation subject, automation and control technologies. Meaning is mm, the processes that are carried out in the last block, that is manufacturing process and assembly operations, that can be automated, or that can be sequenced in such a way that the total output, or we can say the total time required for that will be minimum, and less labor will be used, so that the production rate will be higher. Okay, that is related with the obvious manufacturing system. Also, while automating the processes, material handling technology is another task that has to be considered while providing the material for the different machines and the units. The units means the substations where the processes are carried out. Okay, so material handling is a great uh, task, uh, which uh, to be considered in order to minimize the loss, or reduce the time, or increase the production rate. Also, there should not be any damage for the materials that is being provided at the substations, and the products which are manufactured from the substations that are to be transferred to the another storage area. So that material handling has to be considered in case of automation for the plant or company. Now, this manufacturing system means uh, there we have to consider uh, for what is a object, or what is a unit that has to be produced, or what is the product, and accordingly we have to define, or we have to uh, prepare the sequences for the operations or the processes, and as per that sequence we have to carry out the manufacturing process. So this is what a planning about the manufacturing of the product. Now, after manufacturing of the product, the quality has to be maintained. Quality of that product has to be maintained, and in order to check the quality of the product, there has to be some provisions in terms of parts, or check in terms of some measuring equipments, or some checkpoints, or some quality checking substations which will take care of the size, dimension, surface finish, and loops and all. So that that product will get manufactured to the expected level of quality, and there won't be any loss in case of the material. Okay, because ultimately whenever the product is not satisfying the quality points or quality standards, uh, the material will be uh, considered as a it's of no use, means that will be thrown away, means it will not be taken further for the selling. So definitely that will be a loss to the company, loss to the loss of the material. That means here also we have to consider the automation for the quality standards, or checking quality standards. Then the manufacturing support system, that means here we have to uh, provide the support for the manufacturing of the any product that is for the total plant. So that comes under enterprise level. This manufacturing support system means whatever the data that we handle, or whatever the orders for the material, or the data that we handle with the outside world, or we can say in the plant or different substations, that has to be considered in the enterprise level manufacturing support systems. Here different systems are implemented in order to carry out the manufacturing work very smoothly, and there won't be any problem in case of data handling. That means the data that is coming from the research and development team, design team, production planning team. So that has to be considered, or that has to be systematically handled in order to manufacture the product very smoothly, without any interruption or without any problem. So that handling of the data and handling of the information that comes in the enterprise level. Okay, so here you can see at there are total two sections. One is enterprise level, and one is factory level. Okay, so the manufacturing support system comes in enterprise level, and rest of the things comes in the factory level, because in case of factory level, actual manufacturing is done, and that won't come under enterprise level. And this is, on left side you can see this is what all product this is what total production system, and on the right hand side you can see the manufacturing support system and the information handling systems, and the at the bottom you can on the lower side of the right hand side you can see the facilities. Okay, that means uh, facilities means obviously uh, company or industry will be providing the manufacturing facilities, manufacturing resources in order to complete the task, in order to complete the product. So that comes in facilities. Then, so obviously automation is a technology uh, in which we avoid the human assistance. We try to complete the processes or tasks without human interference. So that is how we are increasing the quality for the product or for the process. Means we are just cancelling out the human errors from the process. So basic elements, obviously the things that are required for this automation is power, then program of instructions and the control system. Because the human is having his brain, so he can decide, he can judge, or he can take the emergency actions over what is happening there about the product or in the system or in the plant. So as we are avoiding human assistance, so definitely there should be some do's and don'ts, if else, and uh, the conditions, number of conditions should be provided for the system, so that it will decide what to do in this case and what to do in that case, what to do in this different case. So number of cases should be considered while writing the program of instructions, and number of control systems will be there which will be performing different tasks, and that means one system may consider safety, one system may consider the actual manufacturing, about actual manufacturing process. Maybe number of processes 1 2 3 4 5 will be involved in the total for the production of the product. And uh, so obviously the power will be required for that system complete to complete the operation, to provide the energy for the systems to work. So the same is considered in the flow chart. That means how they are interconnected, how this power, process, control system and program of instructions are connected with each other, that is shown over here. So you can just explain this things in such a way that the power is required for program of instructions. That means in case of CNC you can understand easily for giving instructions for handling uh, the control system. The control system will be there in case of CNC for fixture, then for movement of the spindle. So number of control systems will be there for coolant. So for providing energy to that uh, subsystems to work effectively and efficiently and without any interruption. Power should be there. Power should be supplied to those subsystems, and the process, in order to, obviously the spindle will rotate and the process will be performed over the product. So for that, obviously the power will be required. Then here, this is all you know about this, that is electricity, that is it's a principal power source. It is widely available, readily available, or it can be converted into mechanical, thermal, lights, and number of uh, way formats. Okay, so uh, that you know how to convert that using different techniques. Then low level power can be used for signal transmission, data processing, and communication. That means whenever we want to go for automation, the power will be required in each and every step on and each and every case and each and every position. So without power, the automation is not possible. It is obvious. Total system will not run without the energy. Okay, and that has to be supplied from the other sources, and obviously the widely available form of the energy that is used in each and every case is electricity, and it can be stored in long life battery. That means one can store the energy. Then here, power to accomplish the automated process. uh, Now for what purposes the power is required, that is just listed or just put up as power for the process and power for the automation. That means to drive the process itself, the power is required to load and unload the work unit. Now, in case of this is in case of the material handling unit, and in case of loading and unloading the uh, workpiece and jobs, then transport between the operations. Obviously, for that case, the power is required. Then, in case of power for automation, you can see here the controller unit. Power is required for controller unit, power to actuate the control signals and data acquisition and information processing. Now, in case of controller unit, obviously we are avoiding the human assistance. Means we are avoiding, or we're just neglecting the use of the human brain, which takes decision during the required condition. That means it may be emergency condition, or it can be regular working condition. So we are just neglecting the human brain. Means there has to be one controller which will take the actions as per the requirement for the plant or for the workspace as per the situation that is coming during the manufacturing of the product. Now here, for so some controllers should be there in the system, which will take the action as per the requirement. So for this case, some logic should be provided, some condition should be provided, and then in one condition what should be done, in second condition what should be done, in third condition what should be done. This all data should be provided for the controller. That means then only it can take the corrective action or the required action in the situation that is coming in the manufacturing plant. Okay, so uh, here human is not there, so definitely there will be some sensors, there will be some cameras, there will be some limit switches, there will be some sensing devices which will check the situation status of the system, and it will uh, try it will send it to the controlling unit. Then the controller unit will it will not think actually, it will just check what is the data provided in the program, what is the logic provided in the program, and it will just check this is 1, so we'll have to match it with 1. This is 2, so we'll have to match it with 2. This is 3, then we'll have to match it with 3. And in the 1, we have in case of 1 condition, we have to go for this action. In case of second condition, we'll have to go for another action. In case of third condition, we'll have to go for another action. So this is how it will just take the decision, because that data is already provided in the program, that logic is already provided in the program in the controller. Okay. So this is what one will take the decision, what action should be taken uh, in the system during manufacturing for the unit or product. Then the power to actuate the control signals. That means the sensors that are taking the or extracting the data, or which are sensing the things from the system, from the plant, power will be required. Also, some action will be taken as per the situation which is coming in the plant. Uh, so to take the action, some actuators will be required, and to actuate those actuators, that means the moving equipments, or the equipments, or the units that are giving motion. uh, so ते वर्क करण्यासाठी पॉवर तर ऑब्विसली लागणार, definitely. So after that it comes data acquisition and information processing. That means after taking the action over as per the situation, as per the required situation, obviously it's suppose टेम्परेचर सेन्स केलं गेलं, खूपच टेम्परेचर वाढलं, दॅट मीन्स कुठेतरी फायर सिच्युएशन आलेली आहे. सो डेफिनेटली सपोज तिथे स्प्रिंकलर्स असतील त्या प्लांटला, सो दे विल जस्ट pour the water over the all over the plant. सो तिथे सगळीकडे पाणी पाणी अशी सिच्युएशन होईल. सो डेफिनेटली सम feedback system should be, or data acquisition system should be there, or information processing system should be there, which will just check आग भिजले की नाही, और सगळीकडे वर्स्ट सिच्युएशन झालंय का, सगळे पाणी पाणी झालंय का, कुठे काही प्रॉब्लेम तर नाही आहे ना, अननेसेसरी पोझिशन लोकेशन्सला कुठे water sprinkling होत आहे का. So everything it will just check. So definitely it will need the power. Okay. That means हे जर चेक करायचं असेल, सेन्स करायचं असेल, प्रोसेस करायचं असेल, so definitely power will be required for this. Then next is program of instructions. The set of commands that specify. So in case of program of instructions means which type of commands will be there, that you can see the examples, that is temperature setting, then axis position, then motor on or off, coolant on or off, so number of the speed. Okay, so number of things are there, number of commands, number of instructions will be there, and CNC will take the action according to that. Okay, so here uh, we have to give this set of instructions the logic, and as per that CNC will take the action. So this is what the required in case of program of instructions. This is the next slide, that is decision making in a program work cycle. So here you can see the main points, that is operator interaction, um, what operator should be done, that is what ATM. You can see automated teller machine. Then different part or product styles processed by the system, that is robot welding cycle for two-door versus four-door car models. Then variations in the starting work units, that is additional machining pass for oversized sand. So next is features of work cycle program. Uh, in case of this features of work cycle program, uh, manual so manual participation will be there. That means loading and unloading of the parts, then fixing and by using various fixtures, keys for locating the number of tasks will be there, which the human or the person can interfere in this automation system. Also, in case of um, assembly of cars on the assembly line, the number of actions are performed uh, by the person or the operator who is involved in that process. So you can read this point that is related to the work cycle, how this is done, and what are the things in the work cycle program. Then we have already discussed about this in the last semester, that is about two types of the control system, that is closed loop system and open loop system. In case of closed loop system, you know that is the system in which feedback is required, and the output need to be checked continuously. It should be monitored continuously in order to maintain the quality of the product or quality of the process. In such a case, we need to consider the sensors or feedback elements by using which we can control the quality. That means if the quality is not to the expectations, we can add up the input, and we can add the we can manipulate the signal, and we can uh, take the output to the required level. Such provisions are not there in case of open loop control system. These are very simple and less expensive, obviously less expensive, as one is not using any sensor or feedback element or feedback system into this. That means it will just sprinkle the water in the lawn, sprinkle the water in case of fire situations. Then it will just open the door. It will not check who is there and how many are there in the line for coming in from the coming inside from the door. So this are the simple things that need to be considered in case of automation of the systems, of the processes. Then these are the simple layouts for the open loop and closed loop system, which will easily tell you what is open loop system and what is control, what is closed loop system. Now first is a closed loop system, that is input is given to the controller. Controller will take the action, and take the decision, and it will give signal to the actuator. Actuator will perform its task. So process will be carried out, and the output will be taken from the system, and the quality of the output will be checked by using feedback sensor. It will be given to the controller. Controller will take the action as per the logic provided in the set of instructions and in the program. So this is how the cycle will run, the system will run. In case of open loop system, the controller will take the action as per the code or the conditions or the set of instructions given in the program. Then the actuator will perform the task and the process will be carried out. That's it. The quality of the process won't be checked later. It will just give the output from the system. It's one simple example of one axis position control system consisting of lead screw. No servo motor is used because servo motor takes the feedback and it will work what is the requirement for getting the required position, and it will just take the action as per the requirement. That means it will move forward or it will come back. Okay, so definitely, you can see here, you may see here the object needs to be there on the work table, and work table should be moved from one position to the second position. You can see the actual edge. Where the optical encoder is there, it will change the position of the work table, and as soon as it is sensing in the position, the motor will be turned off by the controller. Okay, so the position feedback is given to the controller to give the instruction to the motor. So this is the example for the closed loop system. Now in case of open loop control system, obviously you know all these points. You can read these points. So we'll discuss these points later. We'll just stop here. Thank you for patient listening. प्लीज अटेंडन्स द्या सर्वांनी. कालचीच लिंक यूज करायची आहे. थँक्यू सो मच.